Hello and welcome back to the channel. Today we're doing lesson 2 on numeral systems. In the previous lesson we've done conversion between binary numbers to octal numbers. Just to remind you, an octal number is a base 8 number. This means that we can, in base 8 numbers, we can use the digits from 0 to 7. So now we want to see the relationship between hexadecimal numbers and binary numbers. Now, hexadecimal numbers are numbers in the base 16 numeral system. Again, I'm reminding you why I'm emphasizing on base 8, the octals numeral system, and the hexa 16 numeral system, because these two are a power of 2 to the power of 3 and 2 to the power of 4. Now we're gonna apply basically the same principle. Let's look at the following binary number. When we converted a binary number into an octal number, we divided the original number into multiple parts from right to left, and each part took from the original number 3 digits. Now why 3? Because 2 to the power of 3 is equal to 8, and 8 is the base that we want to convert into. It's the same thing with hexadecimal. It's the same thing when we want to convert into hexadecimal, binary to hexadecimal. Now 16 is equal to 2 to the power of 4. So in this case, for this number, we're gonna divide the number from right to left, and each part will take 4 digits, not 3. In order to convert this binary number into hexadecimal number, we need to know a little bit more about the hexadecimal numeral system. Now, the hexadecimal numeral system have 16 digits. Currently, we only know 10 digits. 0 to 9. 10 digits. Now we need to add another 6 to base 16, because in base 16 we can build a number from 16 digits. The other 6 digits are A, B, C, D, E, and F. Now A in a decimal numeral system signifies 10. B will be 11, C will be 12, D 13, E 14, F 15. For example, this is an hexadecimal number. Now that we know which digits could be in an hexadecimal number, we're gonna try to convert this binary number into an hexadecimal number. Remember what I said before, we need to divide this number into parts, and each part contains 4 digits. We're always starting from right to left. Let's do it. So here we're gonna, the first part will be 0 0 1 0. This is the first part. 1 0 1 1, second part. Third part 1 0 1 1, the same. And the final part is 1 0 1 1 1. To make it easier for ourselves, we are gonna convert each part into a decimal number. We did that in the first lesson, so if you forgot, you can go and check it out. Let's see what's the answer for the first part. It's 2 to the power of 0, the digit to the power of the weight, multiply, sorry, the base to the power of the weight, multiply by the digit 0 plus 0 the digit multiply by the base to the power of the weight 1 plus 1 the digit multiply by 2 to the power of the weight 2 plus 0 multiply by 2 to the power of 3 the weight. And here the answer is 4. And 4, now this is 4 in base 10. What is 4 in base 16? It's the same answer, 4, because look at the table that I table that I did in here, and you see that 4 is in this range of number from 0, in this range of digits from 0 to F. Let's do the second part a little bit faster. It's gonna be 2 to the power of 0 plus 2 to the power of 2 plus 2 to the power of 3. And here the answer is 1 plus 4 plus 8, which is in this case 13. And 13 in our case is D. Of course this is 13 in base 10. When we convert 13 in base 10 into base 16 hexadecimal, we get D. Just look in here and you can see the conversion. Remember to learn this table by heart or just comprehend it, because it's not that hard. This is the same part, this is the same digit, like series of digits, so the answer will be the same, D. And here we have 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3, and the answer will be 2 plus 4 plus 8 equals to 14 base 10. Now 14 in base 10 is equal to E in base 16. The final answer will be that this whole binary number is equal to E D D 4, and we write the base in here 16. Note that if we had another digit to the left and it's 0, it doesn't really affect us, because when we're dividing the number into parts, we will get one part with a 0, and we need to complete to the left another 3 zeros. Now it does become relevant when the number to the left is 1. Because then when we do our partition, when we do our division from right to left, we will end up with, in the final division, with only 1 in here. So we need to add 3 zeros to the left, and the new number will be 1 EDD 4 in base 16. Okay, let's do a small revision. This is the formula to convert a number in a specific base into base 10 when D is the current digit that we're working on, multiply by the base to the power of the weight. Let's look at the following number in base 16, F1A3. Of course, we write the base in here, Now this is equal, using this formula, to 3 multiply the current digit 3 multiply by the base, in our case it's 16, to the power of the weight 0 plus 10, a is 10, remember that, multiply by 16 the base to the power of 1 plus 1 the current digit multiply by the base 16 to the power of the weight of the digit 2 plus f is 15 multiply by the base 16 to the power of the digit, in this case it's 3. The final answer is 61,859 in base 10, of course. Now we're gonna do the opposite. Let's convert a number in base 10 into a different base. For example, let's take 179 in base 10. What we need to do is divide this number by the base that we want to convert into. In this case, just for the sake of the exercise, let's convert 179 in base 10 into a number in base 2. So 179 divided by 2 is equal to 89 with a remainder of 1. This is correct because you can write that also as 89 plus a half, which equals to, if you do the common denominator, you will get the same thing, 179 divided by 2. Okay, let's continue. We take the result 89 and we divide it by 2, and again the answer will be 44 with the remainder of 1. Now it's very important to write the remainder, okay? I will explain it at the end. We do the same process. We take 44, we divide it by 2, and we get 22 with a remainder of 0. Again 22 divided by 2, the base that we want to convert into. The answer will be 11 with a remainder of 0. 11 divided by 2, the answer is 1 with a remainder of 5 with a remainder of 1. 5 divided by 2, the answer is 2 with a remainder of 1. 2 divided by 2, the answer is 1 with a remainder of 0. And 1 divided by 2 is equal to 0 with a remainder of 1. Now, when do we stop? We stop when the answer is, in here is 0. When we get to 0, this means that the process has ended, okay? To extract the answer from all of this, we need to write the remainders from down to up. This means that 179 in base 10 is equal to, I'm going to write the remainder from down to up, 1 0 1 1 0 0 1 1 in base 2. This is how we convert a number in base 10 into a different base, in this case 2. We take the number, we divide it by the base that we want to convert into, Then we write the result like this, the result and the remainder, and continue to divide the result until we get 0. After that, we write the remainders from the following orders, from down to up. Let's do another quick example. Let's convert 467 in base 10 into base 8. I'm gonna follow the same logic. So 467 divided by 8 is equal to 58 with the remainder of 3. Now 58 divided by 8 is equal to 7 with a remainder of 2. 7 divided by 8 is equal to 0 with a remainder of 7. Because we reach 0 in here, we stop. Now we need to write the remainders from down to up, and the answer will be 467 in base 10 is equal to 723 in base 8.